Hey guys, Mr. McKinney here, just recording the videos that I would be doing live teach if I was able to see you guys every day in this unit. So the entire unit 10, or at least the first 4 days, are about area and volume. So I've taken this question from 2013 and we're going to break up parts A, B, and C onto days 1, 3, and 4. And then I added a little question in here that we're going to do for day 2. So it wasn't actually part of the AP exam, but I wanted to make sure we had one that matched up with the disk method. Part B matches up with the washer method, and part C matches up with the known cross-section method. So this first video is just going to be doing part A. So let's go ahead and jump to this slide where we're going to be doing part A. So we've got function f of x, which is a quadratic, g of x, which is a cosine function, and then R is the region bounded by those two graphs as shown. Theoretically, these graphs might cross somewhere else, but we're only going to worry about this part of it. And it turns out that these are the only two places that these two graphs cross. Now, before we do anything else, we need to figure out which of these curves is which. Like, I have both of them graphed, but it doesn't tell me which one is which. So f is a quadratic with a positive leading coefficient, so it should be concave up. G is a cosine function, so it should start at 1, in this case start at 4 because we've stretched it by 4. So the cosine function is this one on top, and then the quadratic is this function on the bottom. Now, if I want to find the area of R, so from the other videos that you should have already watched, basically we're going to be doing the integral of top minus bottom with respect to x. And all these functions are in terms of x, so it's easiest to do it with respect to x. In theory, we could make this in terms of y, but it would just be a whole bunch of work and we get the exact same answer. All right, so in this case, my top function is g of x and my bottom function is f of x. Now, since we're doing it with respect to x, my limits need to be x values. So I'm not worried about this 4 up here. I just care that they do cross there, but the 4 is not going to go into the limits. I'm going to use the x value of 0 and the x value of 2. So we're doing the limit from 0 to 2 of top minus bottom. So we're really going to be doing the integral from 0 to 2 of g of x minus f of x dx. A lot of times you'll see braces here. Technically, you don't need them because the dx implies those braces with the integral symbol. Now, g of x minus f of x is just the distance in between these two curves. So at every given point between 0 and 2, we're finding the distance in between these curves. And then essentially, we're just adding up all these vertical lines. So we're getting infinitely skinny rectangles, and we're adding up infinitely many of them to find the area between G and F. So setting it up is the only part that's new. Once you've set this up, and this part right here would get you 1 out of the 4 points that this is worth, the rest of it is back from Unit 7 and Unit 9, where we're just doing integration by hand. This is number 5, so this would be on the non-calculator portion of the AP exam. So I'm going to walk through it, but everything here on out is review. The only part that was new was getting to this step where you set it up, the integral from 0 to 2 of the top minus the bottom. All right, so let's do some math. 0 to 2, g of x is going to be 4 cosine of 1/4 pi x minus f of x is 2x squared minus 6x plus 4 dx. Now, some students are able to do it all in one giant integral. Some students are going to prefer to do 2 integrals. Some students are going to prefer to do 4 integrals. I'm going to do 4 separate integrals to make it easier to follow, but this is not the most concise or the quickest way to do it. So you can just do it all as one giant integral. I'm going to split it up as separate integrals. So I'm going to pull the 4 out for this first one. So 4 times the integral from 0 to 2 of cosine, instead of 1/4 pi x, I'm going to make it pi over 4x dx. And then I'm going to go ahead and distribute this negative and break it up into separate integrals all at the same time. So minus the integral from 0 to 2 of 2x squared dx plus the integral from 0 to 2 of 6x dx, and then minus the integral from 0 to 2 of 4 dx. So make sure you distribute your negative. You can either do it as 3 separate integrals here, or make that one big integral, or make the whole thing one big integral. But I think it's easier to at least separate the g and f parts of it. Again, everything from here on out is review. Most of you guys will not have too much trouble doing this part. This part is just the power rule. So the integral of 2x squared, we're going to have negative 2x cubed over 3. Integral of 6x, we're going to have 6x squared over 2. And then the integral of 4 is going to be 4x. Now each of these needs to go from 0 to 2. Since I wrote it out as 3 separate integrals on the top, I'm going to write it out as 3 separate integrals here as well. And again, now I just need to plug in 2 and plug in 0. Correctly integrating this part is worth another point. And then if we correctly integrate the cosine part, that is going to be worth our 3rd point. And then plugging the numbers in and getting our answer is where we'd get the 4th point here. Now, this is the more challenging part for most students. Most of us know that the integral of cosine is sine, but it has to be cosine of u du. Right now, we have more than just x in here, so I need to make sure that I have the derivative of the inside function. Now, some of you are going to prefer to put everything into u and then never go back. And normally I do that. In this case, I think it's actually a little bit easier to go back to pi over 4x, and I'll show you what I mean. So off to the side, I'm going to say u is equal to pi over 4x. So then du, pi over 4 is just a constant. Instead of x, it'll be pi over 4 times dx. So if this was my u, to get du, I would need a factor of pi over 4 on the inside, which means I need a factor of 4 over pi on the outside. So on the outside, I have 16 over pi. This is cosine of u du. So the integral of cosine of u du, sorry about that. So again, the integral of cosine of u, and then this is my du here, would be sine of u. Now, I'm going to just leave the limits as 0 and 2. So I don't want to put u, I want to go back to pi over 4x. And again, this was evaluated from 0 to 2. At this point, I've gotten 3 out of the 4 points. I need to plug everything back in, or plug the values of 2 and 0 into each of these in order to get the last point. I don't have to simplify, I just need to plug the values in. So if I stop here, I'm at 3 out of 4 points, and then when I actually start plugging things in, that's how I'll get the 4th point. So I would have 16 pi, and then I'd have sine of pi over 4 times 2 minus 16 over pi sine of pi over 4 times 0, and then plus, here we've got negative 2 times 2 cubed over 3, and then minus negative 2 times 0 cubed over 3, plus 6 times 2 squared over 2, minus 6 times 0 squared over 2, and then plus negative 4 times 2 minus negative 4 times 0. Now, if I just stop here, this is full credit. So I can stop here, put a box around it, and move on to the next question on the AP exam. If this was multiple choice, or if you just want to practice simplifying, let's go through and do that. So all these terms that have a 0 are going to go away. So I can get rid of all those because multiplying by 0 goes away. Sine of 0 is 0, so this also goes away. So we've got 16 over pi, sine of this is going to become pi over 2. And then we've got negative 2 times 8 thirds, so that's going to be negative 16 thirds. Then we've got 6 times 4 divided by 2, that's going to be 12. And then we've got minus 8. Sine of pi over 2 would be 1. So we've got 16 over pi minus 16 thirds. Together that's 4. And I'm going to make that into 12 thirds. So the negative 16 thirds and the 12 thirds would be negative 4 thirds. So my final simplified answer is 16 over pi minus 4/3. But again, I don't have to simplify. I can stop at this step and I would get 4 out of 4. Most of this was really from unit 7. Anything below this line was really from unit 7. So if you were struggling on this part, go back to unit 7, rewatch some of those videos, do some of the math XLs to get the practice that you need. So again, this is how you find the area between two curves. Just do the integral of the top minus the bottom. That's for with respect to x. If you have your equations in terms of y, you'd be doing the sideways method, and Mr. Janssens covers that in his video. So go back and watch those. All right, hope this was helpful. Have a great day.